Hey Pixelers, Michael Haddon here. Today I thought I'd give you an introduction to Tailscale because I deal with lots of companies who have distributed development teams all over the world, right? And they need a secure way for those developers to be able to access their internal resources hosted in Kubernetes. Especially since, COVID, we have a lot more remote first companies. So having a solution like this is, in my opinion, essential to any company operating in the modern age, right? So let's have a quick look. So this is Tailscale here, and as it's advertising, you can get secure remote access to anything you want. Now, you might think, well, how's this different to a VPN? Well, it is essentially a VPN. But the reason why I really like Tailscale is it's what you call a mesh VPN. Essentially, you don't have a central server for you to manage, configure, maintain, have to patch and work around in order to operate your VPN. The idea is you can get your services to talk peer-to-peer. Now, you might already be familiar with the technology that Tailscale is built upon, which is WireGuard, but the reason why I really like Tailscale is it makes it really easy to use with this nice interface, its integration with mobile phones, any sort of device you could think of. It just seems to integrate seamlessly, and that's one of the reasons why I like it and I recommend it so much. So let's see if we can implement this with a Kubernetes cluster so we can access any resource we deploy on the cluster locally and securely from my local machine here. I'm going to be using Google Cloud, so I have a environment already set up here on Google Cloud GKE. So we're going to deploy a little Nginx deployment here and see if we can access that securely from my local machine. So let's get stuck in. So the very first thing I'm going to do is I'm going to start a new Helm project in my repository here. And I can do that very simply by just doing Helm create Tailscale. And this will give me some basic manifests to get started. To be honest with you, it gives you a bit much to begin with, so we can start deleting a lot of the stuff here. The reason why I'm going to be using Helm is I am going to use the official Tailscale Helm chart as a dependency for my chart. I like this design because if you ever use a chart which has CRDs, you can now use those CRDs directly within your Helm template, and it will automatically make sure the dependency is installed first, therefore making it very easy to code. So you can use the CRDs straight away in your code without having to worry the order of how you install things. We have this example code here, a lot of rubbish to begin with. Most importantly, we have our chart.yaml file here. I'm going to delete a lot of these comments, so we have less code to look at. We also importantly have our values file. Most of this can go, so I'm going to delete the values file. For now, to keep the project simple, I'm actually going to delete everything in the templates folder. We're going to add stuff there shortly, but let's just clear it all out. So we have a nice empty Helm chart here. So let's have a look at the official Tailscale operator Helm chart, because we're going to install the official Tailscale operator into our Kubernetes cluster, which will allow us to easily expose resources without having to do any of the complicated logic ourselves. So if I go to Google, I can just search, Kubernetes operator for Tailscale, and I can come to the page here. And if I scroll down, it will tell me how to add the Helm chart here. So it's always a good practice. You don't need to do this all the time, but it's always a good practice to make sure you add it locally. And the reason is then it makes it very easy for you to search the repo locally and be able to pick the version of a Helm chart that you want. So here, all I'm doing is Helm search repo Tailscale and -L, and I can see all of the historical versions. If I don't do -L, I just get the current version, but this can make it very easy for me to affix my version of a Helm chart to a known good version which I like. So let's add our Tailscale operator dependency to our Helm chart. So we do that by just adding a new dependencies block. The name will be Tailscale operator. The version, we're just going to pick the one that we see down there. You can also, if you want, I always do this out of habit, but you can add a condition. So you can conditionally enable dependencies as you wish. And it's always useful to make sure you add the repository here. So let's do that like so. And now if we just do a Helm dependencies update, it will download into the charts folder our dependency here. So we can see that like so. If you're using Git, you would probably want to make sure you have a git ignore and you're ignoring this folder, if you want to commit this later, because otherwise you're going to be just like this. Otherwise you're going to be filling up your Git repository with loads of these zip folders. What we can now do is we can do a dry run just to see what would be created. So if we do Helm install dry run, just give it a random name, give it a directory. And we'll see here, these are all of the resources that the Helm chart is going to create if we deploy this into our Kubernetes cluster. So we're not quite ready to deploy yet. It's always my recommendation whenever you use Helm to always have a look at that Helm chart itself so you can see what is actually going on. I just happen to know that this Helm chart is stored in the Tailscale repository, so we can just see if we can find that here. Go to CMD, Kate's operator, deploy, and then chart. And we can see here, this is the actual manifest that we have installed. So if we go to values.yaml, we can see all of the possible values that this chart supports. It's always a good idea, like I said, to always check this out before you actually ever deploy a Helm chart, because sometimes, by just checking this out, you may go, oh, that's what I need to change, right? Oh, that thing needs to be changed, that thing needs to be changed. So if we can just have a quick look at it, we can also get an understanding of what it is that it does. So we do want it to install any CRDs that it creates. We can see here that it talks about having an OAuth configuration here. So we need to define the client ID and client secret in order to authenticate to Tailscale. We can see here that there is default tags that the operator uses. We'll go over that in a second. And we can also see here that there's options like this. So we can expose the Kubernetes API server. So this will allow us, if we want to be able to authenticate to Kubernetes with our Tailscale accounts. So we don't need to manage the authentication layer itself for operators to be able to manage Kubernetes. So if we set this to true, then the Tailscale operator will act as an authentication layer for Kubernetes API server. So we'll be able to control Kubernetes if we turn that to true. For now, though, we're just going to focus on actually just deploying an application and gaining access to it. So if we go back to our Helm chart, we can go to our values.yaml and we'll be able to override the configuration of this dependency by putting in values into this file. We can enable it to true with the condition here, and that's my mistake. This should say .enabled, so we're actually specifying which value to use here, so we can say it is enabled. And then we're going to have to configure the OAuth secret here. So if we recall correctly and we go back here, we can see it's client ID and client secret, just like this. Now, it is generally, obviously, insecure to put these secrets here. We could handle this in different ways. One of the ways when we do dry run is we could do -- set string and use this to override it in the terminal, which might be your preferred option if you're using this in a pipeline. So you'd be able to do client ID equals blah, 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 blah. Obviously, for production, that's still insecure. A better way to handle it, if you go into the chart and we have a look at the template, usually it's always a good idea just to dive into the template itself to see what it is doing so you can get a good understanding how to mutate it to your exact needs. And we can see here, if we do not set the OAuth here, then we can set the secret here from any other source. So that source could be coming from something like external secrets, manually creating that secret somehow, or alternatively some sort of cloud integration that exists to be able to automatically deploy the secret into your cluster. So AWS and Google Cloud have tools such as that. However, for now, for simplicity purpose, we're going to define it in plain text, in plain sight, just to get something working. So the way that you do that, as it mentions in the documentation here, so I've already created a Tailscale account here, and I go to settings. Then I can go to OAuth client, and I can generate an OAuth client. So I'm going to call this, I don't know, Kubernetes cluster. And just as it says in the documentation, the only thing we need to enable here is devices. Now, the problem is there's no tags that exist inside of my organization. I've not defined any tags to be able to say what things this OAuth client is managing. So let's close that for a second and go over to ACLs, which is under access controls here. Now, this is the configuration of the access controls for the tailnet. This is all defined in JSON, though because it has comments, this is actually probably YAML, because YAML is a superset of JSON. So what we want to do, just as the documentation suggests, we want to change the tag owners, which is currently commented out. This is the default configuration. We want to change the tag owners to include this configuration here. So if we copy that, we can shove that in to our configuration like this. Obviously, remember to add the comma afterwards so it is a valid configuration. Now, the way that this works is whenever a device is added into Tailscale, it has a tag attached to it. And this is how we're able to determine who can access which resources. What we're going to do is we're going to tell the Tailscale operator that it's going to run on this tag. However, the resources it creates inside of Kubernetes will have this tag. And we know that the operator will be able to manage them because we're saying that the owner of this tag here is this tag. So basically, what we're saying is resources with the tag Kate's are managed and owned by resources tagged with Kate's operator, which is going to be the tag we're going to give to the operator. Now, this may seem cumbersome and unnecessary, but this can become very critical if you think of your system supporting possibly multiple operators. So, for example, let's say you had a dev, staging, and production environment, you would probably want a different Kate's operator tag for dev, staging, and production. And those resources it creates would have a different tag here, you know, dev Kate's, staging Kate's, production Kate's. And the benefit of that is that none of the operators will be able to mutate or change any of the devices created by another operator. Basically meaning your Tailscale operator on your development environment wouldn't be able to hijack a device on the production environment. So that's obviously very critical from a security point of view. In this example though, since we only have one environment, we're going to keep it simple. So if we save this and then we go back to settings, OAuth clients, generate a client, put in Kubernetes operator once again, and we go to add tags, we'll see there's options here. So very importantly, we want to give it the tag. So the OAuth client, the thing that's authenticating to Tailscale, will act with the authority of the tag Kate's operator, aka being able to manage things tagged as Kate's. Let's generate the client, and we get both a client ID and a client secret. So I'm going to keep these in plain text for simplicity, because I'm going to delete these things afterwards anyway. And we can add it to my code like this. So we can prove that by just doing a dry run command here. I'm just going to grep the data, so I can see it in a string, scroll up, and I should see here. So string data here, and we can see this is populated inside of the Helm install. If we have a look here, this is my current Kubernetes cluster, where we're currently looking inside of K9s, which is a nice TUI interface tool, so you can be able to see your Kubernetes cluster in real time and all the resources. And as we can see here, this is just an empty GKE setup with the basic resources that it uses for networking. So what I'm going to do is I should be able to just do Helm install Tailscale dot. So we're going to install the chart we just created. Now, if we go to Kubernetes, we should see it creating the operator. We need to check that everything is created as expected. So we can see it. Everything's looking good here. I see the word done there. That's always a good sign that something's working right. And we can go over to Tailscale and see here. So this is my current device that I'm connected to Tailscale with. This is this laptop here that you're looking at me working from. And we can see that I've just deployed the Tailscale operator here, and it's inside of my tailnet. And we can see here that it has the tag of Kate's operator. So that's cool and all, but how do we actually access an application that we've got running inside of Kubernetes? So let's get a dummy application out. I have this very quick Nginx deployment here, and a service for it. So if I do a Helm upgrade, we should see my resources now deployed inside of Kubernetes. So we have an Nginx deployment here, and we should have a service for it here. And normally you can just use port forwarding like this to be able to access it. But the problem with this is not always do you want people to be able to access the Kubernetes API in order to do a port forward. And alternatively, not always do you want the people to access these internal applications to have expertise in Kubernetes. It's a lot easier to be able to manage these permissions and this access from Tailscale for multiple reasons. One, it'll be easy to access these resources from your mobile phones. Two, it's easy for people with less technical experience to be able to access the resources. And more importantly, three, it's a lot easier to lock down who can access what, right? So this is the thing we're going to try to access through Tailscale rather than directly through port forward. So if I delete my port forward, I no longer have access. So it's actually really simple to do once you've got the operator installed. we're just going to create a new ingress. So what I've done here is I've created a new ingress. Very simply, I'm just saying the name. I'm saying the backend that it's pointing to. So it's pointing to the service that I created here called Nginx. It's pointing to the port 80. Very simple. And most importantly, I'm saying it's using the ingress class name of Tailscale. So if I go into Kubernetes, I can have a look at my ingress classes. In this cluster, I only have one, which is Tailscale, which was made when I obviously deployed the operator. The whole point of ingress classes is if with Kubernetes you have multiple ingress types. So if I had, say, an Nginx ingress, a Traffic ingress, for example here, Tailscale ingress, I'd be able to determine very easily which method I want to expose an application with. So right now I can only expose with Tailscale just because there's nothing else inside this cluster. But I'm going to say use the ingress class here of Tailscale. Now, when we upgrade again and we get our ingress now deployed inside of the cluster, the one we just made, we will see that it just made this pod here called TS Nginx. And what this is going to do is act as a proxy so we can expose our application over Tailscale. Essentially, what this proxy is doing is it's joining the Tailscale network. It's exposing the resource that is sitting in front, just like a proxy would. And so I should be able to see it if, once again, I go back to Tailscale and I have a look here, and I see I have Nginx running inside of my cluster. And you can also see that it has the tag of Kates. So remember, all of the resources with the tag Kates are managed by resources which had the tag Kates operator, meaning essentially this machine here can manage the configuration of this machine. So how do you actually access it? So if we go to Tailscale and we go to DNS, we can see that this is our tailnet name. Right now, I have a very generic name here. You can always go to rename your tailnet and it gives you a few choices. You got to pick one. You can re-roll the choices. It's basically names that they have pre-generated. So you might get names like Happy Gopher or something. So what we can do is we can copy this tailnet here and go to our browser and just do nginx dot and then our tailnet and make sure we do HTTPS. Now, after doing all of this, we can be happy to see nothing works. And the reason why nothing works is if we go to our pod inside of Kubernetes, we'll see here it has this error message here, which is could not connect to local server at 443. And that's basically because we have not enabled certificate creation inside of Tailscale. So if we go back into Tailscale, we can go to DNS, scroll down, and where you see here it says HTTPS certificates, you want to enable that like so. And what it's going to say here is it's going to create a different certificate for every machine in our organization. It is important before you do this that you change your tailnet to whatever it is you prefer. And the reason is you'd have to recertify all the certificates for all of your nodes. Then I'm going to go back to my pod. I'm going to restart it. It's probably not necessary. Just so you're aware, inside of Kubernetes, it stores all the configuration for the connection inside of a secret. So when you restart the pod, it doesn't necessarily recreate the authentication for that resource. So we can see here, this is how it's authenticating. It's important to know about this because if you ever have a problem with your authenticating to Tailscale, you should delete the secret, not only just recreate the pod. So always what I do is I delete the secret, and then I go to stateful sets and I delete the stateful set. It will then recreate the resource, the stateful set, and therefore the secret automatically for you. The operator will do that. So if we go in here, and what we can do is we can now try and connect again. And everything's working. So we have a valid SSL certificate, connection secure. It's verified by Let's Encrypt, so we have a valid certificate here. I can come back to the pod's logs here and I see it has no problem. You might have to wait a minute or two for it to start working because it might say something along the lines of creating the certificate for the first time. So you may see that in the logs down there. However, we now have a successful deployment of Nginx that we can access securely from anywhere. Now, in theory, we could now lock down this access quite simply using the access controls by defining groups like it has in this example here. Now, by default, with a lower tier of Tailscale, you don't have an infinite amount of groups. You only have the predetermined groups available. One of the predetermined groups is admins, and we could add our account here for us to be able to say, these are the people that can access certain resources. So if I put in my account here, like such, I'm saying that I am part of the admin group. I could then come down here to where we have the ACLs, and instead of having the accept block like this, I can change it so my group, admins, has access to the tag. For example, here we can do tag Kates. So only people who are admins in this example can access the resources which are created by the Kates operator. That's if you wanted to lock it down. It forces you to determine the port of the machine you're connecting to. So I'll just do that by just saying dot star, but colon star, but I imagine that could be 443. So if we save that, I should still have access. And now just to prove it, if I do a sudo tailscale login and I swap to a different account, but still on the same tailscale network, I can do sudo tailscale status, see nothing else in that network because I don't have permission to. But also if I go back to this page, even though I'm in this network and refresh, it will say I do not have the ability to access that Nginx deployment. So we've securely locked it down. So in this example, only one of the accounts has the ability to access it. So I'm going to swap back to my other account. And just to prove I tried from another account, if we go back to Tailscale here, you can see that I just tried to connect from ThinkPad 2022-1, which was actually from the other account. So same device, other account. And that was the device I was unable to connect from because it came from a different username. So if I clean this up by just removing that machine, and for now, for simplicity's sake, I'm going to put back the previous ACL configuration just because it makes it easy to demo stuff going forward. So we're going to do star and star, star colon star, just like that. And we have access again because we just opened it up completely again. Now, it's always useful whenever you use Tailscale to always have a look at the output of Tailscale status, because it gives you a good understanding of everything in your network and how you are connecting to the different devices. The most important piece of text here, in my opinion, is this single word here that says direct. So what that means is it's saying that I have formed a direct connection, a direct peer-to-peer connection with this Nginx proxy. So just to remind you, in your traditional VPN, you would have a VPN server that you have to maintain. You would have your different endpoints connecting to this server, and all of the messages will be routed through this central VPN. In a mesh VPN, it works slightly different. The whole goal with a mesh VPN is instead of everything going through the VPN, you want to end up in a situation where they're able to form their own direct VPN peer-to-peer with the other node. Now, the underlying technology that makes this work is WireGuard. So you may be familiar with WireGuard already, as I've mentioned before, but WireGuard is the new cool kid on the block when it comes to VPN technology, because it's a very lightweight and very performant. Normally with a VPN, you're constantly having to measure the overhead of the VPN whenever you're trying to measure for performance. WireGuard is so extremely lightweight. It is honestly quite amazing. The difficulty is running your own WireGuard. While you can get it running quite quickly for one device to connect to the other, if you were to manage a whole network, it's going to get quite complicated with all of the rules you need to set up. Additionally, it can get quite complicated when you're dealing with situations where there's firewalls in the way or other weird configurations which get in the way of your communications, right? Now, Tailscale gets around this by, instead of having a VPN server in the middle, they have their coordination servers. And so the way that this works is, instead of creating a direct peer-to-peer connection, you actually start by making a request to the coordination server, asking it essentially, how can I make this connection efficiently with the other side? And the coordination, sometimes, in the best case scenario, can say, hey, I know this node over here is publicly accessible on, this public IP address. Why don't you just connect directly? And in that situation, happy days, we can just connect directly. Simple. Sometimes, though, it's not that simple. For example, let's say both sides were behind their own home network, so they're not publicly exposed machines to begin with. Making the direct connection between the two nodes becomes a lot more difficult, because you'd have to have some sort of way of traversing to the other side. That's when we have the whole concept of UDP hole punching, and basically what happens in this situation is both ends make a request to the coordination server, and when they do that, they tell the router that sits in between that they're expecting a response on a certain port. So the router is waiting for a response, and when the coordination receives the message, they will know, hey, this is coming from, this public IP address, right? And they're waiting for a response on this port here. And when it's got a message from both sides, we're both on this public IP and we're both expecting a response in this port, the coordination server can then tell both sides, hey, I now know how you guys can talk directly to each other. So in that situation, while it takes a bit longer to set up the connection, this is still a perfectly fine scenario. Now, there is the other scenario which can happen, which is, let's imagine you're working from a hotel. It's quite common for hotels to block loads of ports because they don't want people doing weird activities on their network. Or alternatively, you could be in a really locked down corporate network and once again have quite a lot of your ports locked down. So you can't just tell the router, hey, can you open this port so I can expect a response? Now, in that situation, the coordination server acts slightly differently. So instead of facilitating a direct connection, you end up in a situation where the coordination server actually acts like a traditional VPN and routes your traffic through it. And the reason why it's always useful to check with Tailscale status is it will tell you here if it's going through an indirect connection. The terminology that Tailscale came up for this type of connection, they call a derp server. It has a few backronyms, but it's called a derp server, from my understanding, because it's an unintended compatibility mode. The last thing for us just to talk about very quickly is how do we actually access the Kubernetes control plane API using Tailscale? Because, for example, with Google Cloud, I can just use their Google Cloud authentication commands to be able to access Tailscale. However, in order to do that, we can scroll down in the values YAML file, and we can find here the API server proxy config and change the mode to true. Now, this won't just work initially because you'll still need to be able to authenticate to Kubernetes. So we're going to have to specify the users and the roles inside of Kubernetes. And once we've added this, we can upgrade our Helm chart, just like before. I can see here that it's just recreated my operator automatically for me with the changes. So I should be able to connect. And the way that you do that is you just use this command, tailscale configure kubeconfig tailscale operator. I'm getting the name of the operator from the name of the deployment here. Therefore, it is important, if you did have an environment with multiple operators, not only do you have multiple tags set up, but you will also have multiple operator names set up. Just like you see here, it says host name, tailscale operator. You would need to give each operator its different host name. So if we do this, I should be able to connect to Kubernetes. But just like I said, I also shouldn't be able to see anything because I've not set up what I can actually see. And when I do try, it says my user here, mhaden at GitHub, is forbidden from listing pods. So we can quickly fix this by making a cluster role binding like this, where I'm basically saying that this user here, mhaden at GitHub, has access to the cluster admin cluster role. And that should be a default role in Google Cloud as well as other Kubernetes setup. If your environment doesn't have a role like this, then you can always create a normal role binding and role as normal in Kubernetes to be able to specify more granularly what that person has access to. But in this example, let's just do a cluster admin so we can see that it works. I will have to, in order to apply this, swap back to my other method of connection to Kubernetes though. And now I should be able to apply this cluster role binding, which should mean if I now configure it for the Tailscale operator, I should be able to get all the pods just like that. So this is another way that you can use the Tailscale operator to be able to authenticate to Kubernetes. And then, like I said, for everyone in your organization, you can create different roles, role bindings, for them to be able to access the resources that they should be able to access. So thank you very much for checking out this video. I hope this has been really helpful in helping you get set up with Kubernetes and Tailscale. In the description, we'll have a link to our white paper which we're working on, which gives our thoughts and opinions on how you should secure your company for a remote first team. So you can make sure that no matter where people are working from around the world, your developers are working securely. And obviously using technologies such as Tailscale are a key component of this white paper. Additionally, if you need any help with your Tailscale setup, please do not hesitate to reach out to me and I'll try my best to give you assistance. Thank you very much for checking out this video, and as always, I hope you guys have a lovely day. Cheers.